Hello physics class. Today we're going to get into some of the bigger ideas in the new unit of circular motion. Alright, and to do so I want you to consider a wheel rotating at a constant speed. Alright, I got this ready for us. So I got this wheel, let me say it's spinning clockwise. I've indicated two locations on the wheel, A and B. I hope you agree with what I've written over here. The velocity here of a point, say there's a rock stuck in the wheel, is going down. Right here it's going down. At B, it's going kind of up and to the left. Alright? I'm going to generalize here, and I hope you agree with it. The direction of velocity of a point on a moving circle is tangent to the circle. Okay? The next drawing, I hope, helps you visualize that. I made the wheel not have any depth, just a circle. Okay? So right here, say there's a piece of gum stuck in the wheel. If it detaches right here, as the wheel is spinning again clockwise, it's going to fly off in that direction. And just simple geometry, hopefully you saw in grade 9 or 10, a tangent line to a circle is perpendicular to the radius at the point of tangency. So that's what I've written here. The velocity is perpendicular to the radius. This is a right angle here. Okay? Now, here's where it gets more interesting. As the wheel turns, the velocity of a point on the outside of the wheel is changing direction. Like, we called this point A. As the wheel turns, point A comes over here to point B. So its velocity was down, but as it goes, the velocity will go to the left, and then up, and then to the right. It's always changing. The direction this point is moving is constantly changing. That's what I want you to be thinking about. Okay, so velocity is a vector. If the direction is changing, that means that the velocity is changing. Direction is part of that. Alright? I'm going to generalize here. Objects undergoing circular motion are experiencing a changing velocity because the direction is constantly changing, so the velocity is constantly changing. Now we have a fancy word for that. Changing velocity is acceleration. Okay? When something's moving in a circular path, you call that centripetal acceleration. So even though the speed doesn't need to change, the changing direction means there is acceleration. Okay? Centripetal acceleration is directed toward the center of the circle that the thing's moving in. Alright? So check this out. This is a good summary of what we've seen so far. I've got my wheel back. I want us to determine the direction of the velocity and centripetal acceleration, point A. Again, I'm saying this thing's moving clockwise. Alright? Velocity is tangent to the circle. It's going to look like that. Okay? But the acceleration is toward the center. I'll just draw it like that.